Let's go on with question 3 of paper 2 for June of 2024. In the diagram, points A, B, and C are vertices of triangle ABC. AB is produced to S. D and F are the x and y intercepts of AC respectively. F is the midpoint of AC, and the angle of inclination of AC is alpha. The equation of AB is y is equals to kx plus 3, and the equation of AC is y is equals to 2x minus 2. 3.1. Show that k is equal to 1/3. So we know that the line of AS or AB has the equation of y equals to kx plus 3. So in order to solve for k, I can substitute the point A into that equation. So we have y is equals to kx plus 3. The y of A is 4. The x of A is 3. And then I can solve for k. So I take the plus 3 to the left-hand side, and that becomes 1 is equal to 3k. And then I divide both sides by 3. So therefore k is 1/3. 3.2. Calculate the coordinates of B, the x-intercept of line AS. So B is on the line with the equation of y equals to kx plus 3. And we already have k is equals to 1/3. So the equation of that line is y equals to 1/3 x plus 3. Now at the point B, we don't know the x value, but we know that y is equals to 0. So we replace y with 0, and that is equals to 1/3 x plus 3. And now we simply need to solve for x. So I take the positive 3 to the left-hand side, and that becomes -3 is equals to 1/3 of x, and then I multiply both sides by 3. So therefore x is equals to -9. Now it's tempting to leave your answer like that, but the question says calculate the coordinates of B. So you need to show your answer as coordinates. So B is -9 for x and 0 for y. 3.3. Calculate the coordinates of C. So C is the point here at the bottom of the triangle, and we can see that C is on the line BC and AC. Now this question would be difficult if you miss information on the coordinates of F. So in the paragraph, they said that F is the midpoint of AC. And we also know that F is on the line with the equation y is equals to 2x minus 2. So if this is the y-intercept, we can find the coordinates of F. So at those coordinates, on the line y equals to 2x minus 2, x would be equal to 0. So therefore the y value is -2. So the coordinates of F would be 0 and -2. And this is the midpoint of the line AC. So I have the coordinates of A, and I have the coordinates of F, and then I can use that to find the coordinates of C. So for question 3.3, we have F as 0 and -2, and we have A as 3 and 4. Let's use our midpoints. So the x of F is equals to the x of A plus the x of C divided by 2. And the y of F is equals to the y of A plus the y of C divided by 2. Now the x of F is equals to 0. X of A is 3. We don't know the x of C, and we divide that by 2. So if I multiply 0 by 2, I have 0 is equals to 3 plus xc. Therefore, the x of c is -3. So let's do y now. The y of f is -2. So we have -2 is equals to the y of a, which is 4, plus the y of c divided by 2. So I multiply -2 with 2, and then I have -4 is equals to 4 plus the y of c. And if I move this positive 4 to the left-hand side, I have the y of c as negative 8. Therefore, the coordinates of c is negative 3 and negative 8. 3.4. Determine the equation of the line parallel to BC and passing through S if S is negative 15 and negative 2, and write your answer in the form of y is equals to mx plus c. So in this question, they actually give us the coordinates of S as negative 15 and negative 2, and they want us to find the equation of the line that is parallel to the line BC. Now, in a previous question, we found the coordinates of B, and that was negative 9 and 0. And in the previous question, we also found the coordinates of C. So I can find the gradient of line BC, and that will be equal to the gradient of the equation of the line that we want. And once we have the gradient, we can use the coordinates that they gave us to find the equation of that line. So for question 3.4, we'll find the gradient of line BC, and that is the y of C minus the y of B divided by the x of C minus the x of B, which is negative 8 minus 0 divided by negative 3 minus 9. And if I simplify on my calculator, I have the gradient of line BC as negative 4 over 3. So therefore, the gradient of the line that we want is equal to the gradient of the line BC, which is negative 4 over 3. So to find the equation of a line, I need to find the gradient and the y-intercept. So we already have the gradient as negative 4 over 3. Now to find the y-intercept, we will substitute the point of negative 15 and negative 2 into our equation. So y is negative 2. We have our gradient multiplied with negative 15 plus c. And if I simplify, I have c is equal to negative 22. So I will simply multiply out on the right-hand side and move that result to the left. Therefore, the equation of the line is y is equal to negative 4 over 3 times x minus 22. 3.5. Calculate the size of angle BAC. So let us inspect our diagram. We want to find the angle size of BAC. So if I highlight a triangle connected to angle A, I see that I have a triangle with an exterior angle, and I have two interior angles. And one of the interior angles is the angle that I want to solve. So the missing interior angle is also the angle of inclination of the line AB. And we know that the equation of that line is y equals to a third x plus 3. So I can find this angle of inclination by taking tan of that angle and setting that equal to the gradient of that line. And that gradient is equals to 1/3. And I can do the same to solve for alpha. So when I find alpha and this angle of inclination, I can use exterior angle of a triangle to solve for A. So for 3.5, we know that the tan of alpha is equal to the gradient of that line. So that's equal to 2. And if I use my calculator to solve alpha, I have alpha as 63.43 degrees. Next, we want to find the angle of inclination of the line y is equals to a third x plus 3. So that angle would be angle B. So let's call that ABD. Tan of that angle is equals to the gradient, which is a third. So therefore, angle ABD can be found by using my calculator again, and that is 18.43 degrees. And therefore, angle A, which we want, is equals to 63.43 degrees minus 18.43 degrees. And if you want, you can put down a reason. That is the exterior angle of a triangle. And that simplifies to 45 degrees. So therefore, the angle of BAC is equal to 45 degrees. 3.6. If it is further given that the length of AC is 6 root 5 units, calculate the value of the area of triangle ABD divided by the area of triangle ASC. So let's identify the two triangles from our sketch. We have ABD and ASC. So what I notice about the diagram is that the triangles share the angle of A, and in the previous question, we found the angle of A to be 45 degrees. Then I see that I have enough information to find the length of AB and the length of AD, also the length of AS, and the length of AC was given. Now the reason why I want to find the lengths of the sides of the triangle, where the angle that we have is in between those two sides, is because it allows me to use the area rule. So remember that the area of a triangle is equals to half BC sine A. And that can be found on our formula sheet, where B and C represent sides of a triangle, and A is the angle in between those sides. So in order for me to find that ratio in the question, I need to find the length of AB, the length of AS, and the length of AD. We were given that the length of AC is 6 root 5. So let's start with a pink triangle. So we can find the length of AS, which is the difference of x values. So that is minus 15 minus 3 squared, plus the difference of y values, which is negative 2 minus 4 squared. And I take the square root of that, and that is equal to 6 root 10. So we have the length of AC, and we have the length of AS. Next, we can find the length of AB. So we'll focus on the green triangle. So AB is equals to the difference of x values squared, so that is minus 9 minus 3 squared, plus the difference of y values squared, and that is 0 minus 4 squared. And I take the square root of that, and that is 4 root 10. Next, I need to find the length of AD, and I notice that I don't have the coordinates of D, but I have the equation of that line. So for D, we can find the x-intercept of that line. So for coordinates of D, we'll set y equals to 0 in our equation, and when I solve for x, I see that x is equals to 1. Therefore, the coordinates of D is 1 and 0. And now I have enough information to find the length of AD, which is 3 minus 1 squared plus 4 minus 0 squared. And I take the square root of that, and that is equal to 2 root 5. Now I can find the ratio that they asked me in the question. So we have the area of triangle ABD divided by the area of triangle ASC. So that is equals to a half of AB times AD times the sine of A divided by a half of AS times AC times the sine of A. Now notice that the halves will cancel out and the sine of A will cancel out. So we simply need to substitute the lengths of the sides. So AB was 4 root 10 times AD, which is 2 root 5, over the length of AS, which was 6 root 10, times the length of AC, which was 6 root 5. So you can do that on your calculator, but what I notice is that the roots of 10 will cancel out, the roots of 5 will cancel out, so I'm left with 4 times 2, which is 8 over 36. And when I simplify 8 over 36, it will become 2 over 9. So that's my answer for question 3.6. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic.